Okay, summing up distributed transactions. Remember that distributed databases were pioneering and a central aspect of all of distributed systems. So if you're interested in distributed systems, you should certainly know two-phase commit. And you should also understand the logging aspects of two-phase commit, which are often glossed over in the distributed systems discussions. Partitioning of distributed databases provides the scale-up that we wanted in parallel databases. And we can also partition our lock tables and even our logs across nodes in the natural way so that things essentially work very much like the single node systems in most respects, with a couple additional protocols. So the additional protocols for global coordination, one is deadlock detection. That one's quite easy, as we talked about. The other one is distributed commit, which is quite a bit trickier and needs to use two-phase commit with proper logging. Two-phase commit is a classic distributed consensus protocol. The logging and recovery aspects of it make it particularly unique because databases have these write-ahead logs that can allow for node recovery. Many distributed protocols gloss over these issues, so keep in mind what you learned in this lecture with respect not only to the two-phase commit messaging, but also the logging. One of the downsides of two-phase commit is it's a unanimous protocol, so it's unavailable on any single failure, and that's bad news for scaling up. The more computers you add to your system, the more the odds are that one of them might fail during the lifetime of your transaction. So the Paxos commit protocol, which is this sort of Super Friends paper by Gray and Lamport, addresses the problem of availability of nodes in a two-phase commit protocol.